yours is first, man. Hi guys, we're going to talk about Apache Falcon. It's an incubating project in Apache. It's been incubating for about a little over a year, and we have had 2 releases, and the third release is coming pretty soon. It should have been out, but for a small glitch in the Apache process. And this is Srikanth.
Hey, I'm a principal architect at InMobi, so I'm one of the contributors and PMC member of this project.
I work as an architect and a lead in the data integration efforts at Hortonworks. I've been, before Falcon was incubated, I was working on Uzi, Scoop, and Flume, and was responsible for making that as part of HTTP. And we both have been at Yahoo before Hortonworks was formed, and we kind of jointly architected a couple of generations of data management software at Yahoo, which is still running in production. So we'll look at the motivation behind Falcon. What were the factors that came together for us to think about a new platform for data management. And we'll look at an overview of Falcon, what exactly is Falcon, and look at architecture, drill down into how things work behind the scenes. And finally, we're going to present a couple of case studies. One is a very simple data lifecycle management case study. The other one is how do we do data process management across data centers, how easy and seamless it is for users to use Falcon primitives and declarative language to express complex pipelines across data centers, across Hadoop clusters. This should be very familiar, right? For Hadoop has been quite successful. People get data in ad hoc way using SSH, SCP, and then use Hadoop CLI, HDFS CLI to typically get smaller data and see the power of Hadoop to derive insights or generate aggregates much quickly and productively. And once they've tasted the success of Hadoop, they want to now do this in a periodic way and take this to production with SLA guarantees and retries, handling all sorts of other business criteria like BCP and DR. A lot of things keep adding on, right? And that's where the challenge comes in. So there is one is different volume of data. The second thing is data quality. Right? Once you have ingested data, you want to make sure the bits match the source. Or once you have replicated across Hadoop clusters, you want to make sure they are the same data. And then once you've started tasting success, you want to now get all the data sources or data from across different data sources into Hadoop, ingest the data, and then once you've ingested the data, if it's business critical, you want to now implement DR, replicating this data across sites. And also, if you have different class of clusters like research, you want the same data for research users without giving them access to production clusters, right? And then once you've gotten your data, people want to express some kind of processing over that data and archive data as well. Because for SOX and SEC compliance, you need to keep the data around for a long time. SEC mandates 7 years, SOX 13 months. If you don't have such large retention on your production Hadoop clusters, you want to archive this to cloud storage or to tape backup or what have you. And then once you have interesting insights derived, you want to now shove these aggregates or summaries or what have you into your reporting systems so that your BI tools can drive drill up and drill down, things like that. So this is a typical landscape we see in the Hadoop and kind of data warehouse scenarios, and said, why not we have a set of tools today, right, which could solve, but people have to hand code a lot of things and work across different sets of tools to accomplish this. So we said, what are the core services that kind of come out of this, right? So in process management, we have relays, right? As soon as data becomes available, you want to trigger your processing. You don't want to delay because SLA, typically jobs are SLA critical. Then we've seen often that data does not arrive on time, right? There are 2 different types of data, right? One that is business critical, which it has audit and stuff. you want to have close of books, but still accommodate late arriving events into that, so that you get the right numbers. So that is something common repeating pattern we have seen. The other thing is retries. You want reliable retries with different policies, right? And you should be able to express them without having to write a lot of logic. Coming to data lifecycle management, you of course want data motion, right? Ingress and egress, very, very critical, and replication of data, which is two-faceted, which we're going to talk about in detail. One is for DR purposes, one is for the case study that I was mentioning about distributed processing. Then, of course, even if you have large petabytes of capacity, we have seen at Yahoo, we kind of max out the clusters. So for capacity purposes, you want to purge older data. The second is compliance purposes, right? You have PII data or some information which cannot lie there for more than 90 days or some stipulated point in time. You cannot rely on users to enforce these compliance policies, right? You need to have a service that manages these policies automatically without relying on users from an operator's perspective. So we provide eviction as a service as well. Then other data governance features like auditing your processing pipelines, auditing your entities in the system, and providing lineage as well, right? You want to see how this data was derived, or how this data came into being, and what were the other data sets that were used, either for debugging purposes or for audit purposes, and SLA. So looking at all this, right, we said, data lifecycle, just data management itself is quite overwhelming, right? And very challenging in spite of, existence of a lot of tools like OZ, Scoop, you have Flume, right? And a lot of other, ETL tools as well, like Talend and Pentaho and such. So what we have seen so far is, a siloed approach. If you build, let's say, OZ workflow for you to, orchestrate a process, you're burning in, the locations of the data, burning in, what your name node is, job tracker is. For some reason, if you're migrating your data from one cluster to another cluster, let's say you start with research data, right? I mean, researchers using this data, and they say, this is really good. I think we can derive a lot of information out of this and, have some effect on the bottom line. So I want to now productionize this, right? I want to move this to production. So how do you do that? In OZ, you'll have to rewrite the workflows, change everything by hand, and it's not easy. If you have a very complex DAG, you have hundreds of lines of XML code and dealing with the nuances of OZ itself, right? And if you want to update something, right, you want to change certain attributes, OZ allows only certain attributes to be changed, and it's kind of really painful to update a coordinator, or you'll have to end the previous one and create a new one. So there are a lot of such things. The second thing is, if you're ingesting data, there are small files problem in HDFS. So since we have worked in these technologies, we understand the limitations and kind of impedance mismatches across these technologies, and said, why not build something on top of these tools that are available without reinventing the wheel, so that we kind of take users, introduce users to a higher layer of abstraction. So that's the intent, and at the core of it, you'll see in the next few slides, you will see what we mean by them. So at the core of Falcon, there are, this is the entity graph, right? There are three entities. One is, infrastructure, which could be a Hadoop cluster, which could be an external system like a database, a filer, right? A NAS or, some filer sitting around, even a FTP Dropbox maybe, right? So these are, data sources that are part of the infrastructure. Then you have data sitting on that infrastructure, right? So we abstract this as a feed or a data set, right? And then you have process that actually consumes or generates this feed, which runs on some infrastructure, right? I mean, here it's Hadoop centric, so all the data that lands and are processed are on a Hadoop cluster. So let's drill down into double click on each of these and see what they actually look like for clarity. So if you look at a cluster, right? A cluster is basically, today it's expressed in XML, but we use JAXP, so you could potentially express this in YAML or JSON, what have you. We don't have a UI today for entering entities, but we will eventually. But cluster essentially is a set of interfaces for specifying different endpoints, right? The first one is a read-only endpoint. So this is HFTP for historical reasons, but you could use WebHDFS as well. and write is the RPC URL, which is HDFS. Of course, since Web HDFS supports both read and write, you could use Web HDFS as well here. Execute is essentially your RM, right? Your resource manager in Yarn if you're using Hadoop 2, or your job tracker URI if you're using Hadoop 1. And workflow, by default, we materialize all the workflows and schedules in Uzi today, which is part of the Hadoop stack. But Falcon has abstracted everything, so you could potentially write a different orchestrating workflow engine implementation for it to orchestrate the different processing and lifecycle management policies in a different workflow engine. Registries are a Hive Metastore registry, which is the Hive Metastore or Edge catalog. Messaging is something that we use for two things: for notifications, to notify users of the progress of different workflows that are running in the system. And also Falcon uses it internally to work with late data handling and retries and stuff like that. So these are some housekeeping locations that Falcon uses to materialize workflow definitions, libraries and things like that. So it's very, very simple, right? I mean, you express this once and reuse this across definitions. We covered this one. So let's look at a feed definition here, right? Feed essentially is a set of files on HDFS, or it could be a table in a Hive. Again, we have a concept of storage. It's extensible. If you have something else, we could eventually express storage as something living on a Hadoop cluster. So here we have periodicity that you express in hours, days, weeks. What is the periodicity of this feed itself, of this data on HDFS, or partitions in Hive? So we'll come to the late data handling in a couple of slides. So this is something, groups and tags are essentially used for logically grouping if bunch of feeds together, like you have set of BI feeds or reporting feeds and things like that, and you can receive notifications based, for that group. Tags are, some metadata tags that we capture for lineage and indexed so that you could, do interesting searches on relationships. So you could have, my external sources, Teradata, this is coming from Teradata, who the owner is, who the publisher is, things like that. And you have this set of clusters here, right? So the interesting thing to notice here is, where does this data exist, right? It exists on cluster primary here. The type is source, it has certain validity, and you're expressing an retention policy, which is eviction policy, declaratively here, saying, hey, I want this data after it's created for 2 days, right? After that, I want to purge this one, and automatically Falcon orchestrates this one behind the scenes. So we have some actions and workflow materialized just for this one single line. A lot of things are happening in the backend, right? The second cluster here, type is target. That means there is an implicit policy here. There is one source, there is target. Automatically, Falcon now knows that you have to replicate this data as soon as it becomes available at the source to the target here. And similarly, you can override the location on the target cluster where this data needs to land in, and then have a different retention policy at the target, right? So typically, if you're copying from production cluster to historical warehouse, you would have whatever 30 days in primary cluster and 13 months retention on historical warehouse. You can have 13 months retention on your target cluster. And this location is common across what is the path on HDFS, right? You can also abstract this to Hive table and say table, and it has a URI, very simple URI like ISBN number. You have a catalog, you have the schema, and then the table name and the partition keys, right? And you could override that for the target as well. And we also have this ACL where who is the owner of this and have permissions, and this is validated whether the user has access on HDFS. And you could provide schema location as well if it's file system. So that is data set. Now you have a process. So this is another cool thing, right? You can now express very simple workflows as a process in Falcon and say, this is the cluster or set of cluster that it runs on. So the moment you add 2 clusters, you have hot processing. That means this process is orchestrated on 2 different clusters at the same time and triggers as soon as that data becomes available on that local cluster, right? And you express some scheduling controls here. Here, If you have more than one instance of the feed that you have defined, how many instances of the process will run, what's the order, we support FIFO, LIFO, and last only. What's the frequency again, what's the periodicity of this process. And you can express set of inputs for this process and a set of outputs for this process. And we support very expressive EL here. So you can have a daily process which is doing a roll-up or aggregates for the last 24 hours. If you have an hourly feed, you can do a roll-up of the last 24 hours and create a daily aggregate, right? And if you have a quarterly feed, you can have take the daily ones or monthly ones or weekly ones and then generate a quarterly aggregate. So it's very easy to do and say 0, 24, it consumes last 24 instances of feed, and that is sent as input to this process automatically, right? And you can have one or more outputs generated for a given process. And here is where you plug in the user workflow, right? Without worrying about how this is orchestrated, how this is working, you basically say, this is the pig script I want to run. We support 3 engines today, which is extensible. Pig, Hive, so you can have a pig script, which is essentially a script that you write and save it on HDFS and provide the location of that script here, and have your own libraries as well. You can specify a set of libraries which will be distributed along with this process to the tasks. We also support Hive script. And the third one is Uzi. So if you have a very complex DAG that you want to express, we don't want to reinvent the wheel. So in that sense, you need to learn Uzi. But to write a workflow specification, or express your workflow as a DAG with decisions, forks, what have you, and then put that here where your workflow is, and that workflow is executed. And again, here retries, right? Which you can express retries with different policies. We have periodic backoff and exponential backoff, and number of attempts here. So those many attempts are retried, and then it gives up once it's exhausted all the attempts. We'll come to the late handling in a bit. So this is essentially very, very simple expression of your infrastructure, data, and your process, and you can stitch basically a pipeline of sorts together where you have chain of processing through the input feeds and output feeds, and that's how we capture lineage as well across your pipeline. So we don't have pipeline as a first-class entity today. We plan to add that so that you can visualize a pipeline, create a pipeline with multiple stages of processing within a pipeline. Okay, coming to late data handling, right? So late data handling defines how your out-of-band data is handled here, right? So your feed definition says this is my cutoff, right? You can define 3 hours or number of hours as your cutoff and say this is how long Falcon is going to accept, right, inputs and watch that for changes, right? And each process will define how late data is handled in this small snippet. So what's your policy and what are your late inputs, right? So as soon as the inputs becomes available, the processing starts. But it still watches for this time based on the policy that you have specified and says, has the inputs changed? If the inputs have changed, it re-triggers your processing, right? So if you have a chain of processing chained together in a pipeline, your complete pipeline is triggered based on this late data handling without any user intervention, right? So it's very, very useful if you have that use case. Coming to retry, we saw retry. Again, we have very simple expression of retry. So in Uzi, the only transient errors were retried, right? And you have to have retry. I think retry policies were enhanced in 4.0. Now you can have per action what the retry policy is. But here you get, apart from the map tasks or the big tasks that you have launched, you get some kind of retries from within the Yarn framework or the MapReduce framework. And then we have coarse-grained retries on top of that. This is something that we added in 0.5, which is about to come out. We capture lineage for all the processing that is happening. We also capture the version of the workflows that were executed, the inputs, outputs, the tags, metadata tags. A lot of things are captured. And you can actually keep drilling down, drilling up, and if you hit a terminal, right, it's grayed out. This is a very simple, there are 2 ingest processes generating 2 feeds, and they're joined together in a process and generates an output feed. And you click on any node here, you get a bunch of properties that were captured and indexed. We haven't exposed any search, but it's very rich relationships are captured, so you could do very interesting things like, give me all the feeds that were actually sourced from Teradata, or give me all the feeds that are secure, owned by certain user, right? So things like that can be very, very easily done. We have captured this data, we haven't exposed that, and in the future, we plan to expose those searches as well. To kind of sum it up, right? In summary, you have a lot of tools in the ecosystem like Oozie, Scoop, DistCP, your MapReduce, Pig, right? So if you have to do this yourself, you'll have to write a lot of code, right? Eviction is not easy, right? There's replication. There are a lot of nuances in DistCP as well. How do you actually, what strategy do you use in DistCP? You have to do a lot of learning. Instead, Falcon kind of abstracts the users away and say, you worry about, what you want to do, right? Of course, we can't alleviate you from Pig and Hive. You have to learn that. But everything else is provided as a service, which you declaratively, specify what you want to do, and automatically, everything else is orchestrated behind the scenes. And again, as we said, we don't reinvent the wheel. We use every single component within the ecosystem, by abstracting the user away from those things. So there is multi-cluster management, as I said, replication, there is scheduling, reprocessing of data, right? The dependencies also, right? So the cool thing that we have now is we have the relationships across these different entities that the user has expressed. So we have the holistic information now to make scheduling decisions, to monitor SLAs across your pipelines, and a lot more that we could do. So now I'll turn over to Srikanth to talk about the architecture.
So on the Falcon architecture, basically, like Venkatesh was mentioning many times during the earlier part of the presentation, that Falcon tries to leverage existing stack and tries to provide these abstractions over it, which means that the Falcon system by itself is not going to do any heavy lifting. It's going to be, leveraging all these tools underneath to, realize these functionalities. So at the core of it, it basically has a simple web server, a REST API enabled on it, which is where the dependency graph and the configurations are maintained. The configurations such as the entity definitions like clusters, processes, feeds, etc., are maintained in Falcon in a storage. When the REST API is used to do the CRUD functions on them. So you could create new cluster, create new process, or modify a process, update a feed. All those kind of operations are done inside Falcon. One of the important steps in Falcon is once you submit these entities, you could then schedule them. There are schedulable entities and non-schedulable entities. Process and feed are schedulable. So once you schedule them, that's when it really goes and creates workflows on Oozie and schedules them for execution. So it basically talks to Oozie in that at that point in time, and then schedules them, and has a link with Oozie in terms of the entity name, so that it's able to talk back to Oozie with that specific entity. So once the control goes to Oozie, Oozie would run pretty much everything on its own. So there is no way for Falcon to know what's actually happening. So then it would just be a job submission system. So what we do is we instrument the user's workflow with a post-processing and a pre-processing step, so that Falcon is in the know-how of what's actually happening with each of these instances that are getting executed. So that's what's done during the schedule process. One of the things that's done in the post-processing of this instrumented action is to send a notification or a JMS message back to the queue, and Falcon listens to this message on a continuous basis. So through this mechanism, what's actually happening right now is that all instances of execution are being tracked by Falcon when it starts and when it completes, and it's able to act on failures for, let's say, the retries, or be able to perform the late data handling when the data changes, for instance, and stuff like that. So it's able to do. So at the core of it, it's fairly simple. So it's got a Falcon server. It talks to Oozie through the HTTP REST interface that Oozie exposes. The H catalog is used to validate and stuff like that, where the feed is based on a H catalog table, and the messaging is the interconnect that allows Falcon to figure out what's actually happening in terms of the runtime. And the process instance status that in terms of tells you, or feed instance status, which tells you, okay, you've set up this replication between these clusters, what's actually happening with it. If you want to realize, if you want to figure out what's happening, the JMS notification is the one which is enabling that information to flow back into Falcon, and that's the information that's used also to update the lineage and build the lineage as well. So let's look at two use cases, feed schedule and process schedule. We will walk through that in a little bit of detail to see what actually is happening. So you have a cluster definition which you have to first set up. You have to set it up only if you have not done it already. So once the cluster is, XML is available, you can schedule it, or submit it in Falcon. The Falcon writes this into the Falcon config store, and it updates the entity graph with all the dependent entities. Because cluster is the first entity, there is no dependency yet established. So the next thing that you would do is to, submit a feed configuration. The feed configuration would then also end up in the configuration store, and the dependency graph is updated saying that this feed is now dependent on this cluster, and that information is retained in the config store. This is as far as the submission is concerned. With submission, there's no real retention or replication, or all those lifecycle functions are not enabled. They're not operating right now. You just submitted, the entity is just sitting in the config store. It's not live right now. So the next thing you do is to schedule them on the system. So when you schedule them, what actually happens is it brings back the configuration from the config store and creates a workflow in Oozie to enact those declarative functions that you have said. Do this retention every 30 days, throw data away, or replicate this data every hour from this cluster to that cluster, or this location to that location. This piece of information is then used, and a workflow is built, and that workflow is then scheduled via Oozie for execution. And in the process, it also instruments the post-processing action and the pre-processing action, so that at runtime, when these functions are actually running, you would be notified of the actual success or failure of these events. This event is then listened by the Falcon server to provide instance status and also retry handling, etc. Instance status also sometimes would go to the Falcon server and may directly land on the Oozie scheduler, fetch information from the Oozie and return it back to the user. So that's the feed schedules lifecycle. So let's look at the another use case, which is the process schedule, and let's see how that happens. It's fairly similar to what happened with the feed. So like the feed schedule, you have cluster and feed which you have already set up, but it's already sitting in the config store and in the dependency graph. So now you set up the process definition. The process definition may depend on one or more feeds, may produce one or more outputs as feeds again, and those also go and sit in the config store. So when the process schedule happens, unlike the feed schedule, in the process schedule, the user is indeed providing some action to perform, or maybe a pick script or a hive or a Oozie action itself. So the whole thing is configured as a Oozie subflow inside a parent flow. The parent flow then provides the post-processing and the pre-processing primitives on that Oozie workflow, and that gets scheduled on the Oozie. So once that is done, you basically realize the scheduling capability. Once the schedule is live, when the instances run, they notify again through the same protocol, through the same JMS messaging, and Falcon server is in the know-how of what's actually happening with those. So that basically allows you to kind of watch the process instance execution and the feed lifecycle function executions. Over to you. So, so in physical, so Falcon actually has two modes of operations. One is a embedded configuration and a distributed configuration. In embedded, what actually happens is you kind of assume that there is only one cluster that or one instance of Falcon globally set up, and that's operating across all the clusters. That's the mode in which it operates. So you could what that means is that you could operate from cluster 1 to cluster 2 using the same Falcon instance, and it is connected to both of them. This is not possible to use if the clusters are running different versions of Hadoop, let's say, or fairly distant away, because the messaging etc. are fairly chatty. So what we have is a alternate way of configuring this in a distributed mode. What happens is that there is a Falcon server sitting on each of the data centers or each of the co-locations, and they manage the clusters and the data and feed in that location, allow you to process the things in a distributed fashion. And there is a component in Falcon called Prism, which allows you to connect them and give a holistic view of what's actually happening across all these data centers. So through Prism, which has almost, exactly the same REST interface as the Falcon server, you're able to realize the same functionality, except that the Falcon servers themselves are only responsible for one data center or one co-location at a time, as opposed to the standalone mode, which operates as if there is only one global location. What is the case study?
Yeah. So this is a very simple case study. This is about data lifecycle management. So you could essentially have a use case where you stage the data, and you have a process where it cleanses and conforms and makes it presentable. So here what we're essentially saying is you could have the raw data or stage data replicate to BCP for failover purposes, and also the presented data. So you'll have a very simple 2-feed definitions here on a process which consumes the stage data and creates the presented data. And this kind of enables a business continuity very easily with just one 2-feed definitions and a process which consumes stage data on the primary cluster and creates the presented data. And as soon as this data becomes available, they're replicated. So the other thing is, if you want the intermediate data, which is cleansed and conformed as separate data sets, you could configure them as feeds and have different retention policies based on your business needs for each of them, and express processing, which consumes and creates these processes. So again, very simple and very easy to actually create these entity definitions and model them based on your needs. So intermediate data, if you want it to be around for whatever purposes, you could have that defined as a feed, and then Falcon keeps it around for however long you want. So this is a very critical feature that Falcon was actually developed for. And this was developed at InMobi, and this is an InMobi use case, which is running in production for 8 data centers. So, yeah. So I would like Srikanth to speak about.
So this is something that we at InMobi leverage Falcon for, most importantly. So we basically have advertising business is what InMobi is in. Mobile advertising to be specific. So in each of the data centers, we basically have different streams of data, like ad request data, impression data, click data, all standard thing that you would see in a advertising business. And they end up in a data center. And what we used to do earlier was to ship all this data into a single mothership, if you would call. Everything would just come to one location, and we used to process this on a continuous basis. What we then re-architected this is we kind of divided and conquered this, where we said each data center would specifically process data for that data center, and then aggregate it locally, and then we would have much smaller summaries or concise information flowing into a central location for further processing or further analysis. So how Falcon is configured here is all the process definitions that you were looking at earlier is defined only once, and you just simply say it's now on 5 clusters, and all of them run simultaneously in each of the data centers. And when you're done with this processing, you just simply declare saying that here are the outcomes of these summaries or outcome of these processes, and they need to be shipped globally to a central location. So you define that in a feed configuration as a multi-source, single target replication construct, and it will happen. The retention is happening on local data centers, specifically within their within each of them, and the replication is happening from all these individual data centers to a global one. And the processing is happening simultaneously in each of these data centers concurrently. So fairly difficult to pull off if you are using combinations of several tools, but it becomes fairly simple for us to manage. So the operations team could just go to the Falcon server and find out what's actually happening globally across all the data centers. They have a quick view of what's actually happening, which processes are at what stage, and what data is replicated, what data is available where. All that is easily available through the system. So that's the use case that we have. We've been fairly successful with leveraging Falcon in this particular scenario, and for all other applications that we have within our company.
Pretty much it. Okay. I mean, we just, as I said, we just did a 0.5 release. Again, it should come out pretty soon. We have security in there. We have lineage. We have Windows support. And we also have archiving it to a cloud store like S3 and Azure. In fact, today's presentation from Microsoft in the afternoon by Matt will feature a demo of Falcon, replicating data from on-prem to cloud. So the future, we'll add more features and governance, audit and lineage, maybe integrating with XI Secure and things like that. There was a talk last morning at the same time on Data Pipeline Designer. So instead of users working on PickScript and HiveScript, we are working on a pipeline designer tool where you could design your pipelines. It provides certain primitives and the feed definition, schema, and things like that. You can actually create a pipeline using a design visually, and then it gets translated to PickScript in the backend, which will then be orchestrated as a process in Falcon. We're also working on authorization. We have authentication using Kerberos today. We don't enforce authorization, so we are working on authorization for the next release. And of course, more meaty monitoring management dashboard, which will have UI to actually create these entities, feed definitions, and things like that without having to go through XML hell. In summary, I mean, as I said, we support both data management and data processing, primitives, which kind of alleviates you from learning different APIs to working with different tools, and give you a higher layer of abstraction to work with. And this is the only component that has user notifications today. So we're open for questions. Again, we have a vibrant community. We have a lot of developers. If you have any questions outside of this room, you can send it to a dev mailing list. It's an open source project, Apache project. And it's also bundled with HTTP 2.1. Yeah.
You talk about data management and data processing together. I understand. So would I be Falcon just doing data management and multiple cluster, and then hand over to whatever tool inside doing data processing, like Pig or Hive, and let them do what they do? I mean, I just don't understand how they connect to, and do you have to use new language like database pipeline to hand over the Pig and Hive? Right? So my question is like, is it should be just data management, or do you think like data processing also should be included as part of that?
If I understand your question is essentially it's not very clear, where Falcon ends. Does it also do processing, or should we use Pig and Hive for processing? Is it?
Absolutely. Like if we're
Okay.
hand and we're to other existing processing, where it's pipeline stuff.
So that's a good question. So Falcon does not reinvent the wheel, right? I mean, we don't want to reinvent processing. We already have in the Hadoop ecosystem, MapReduce, Thais, then we have Pig, Hive, the higher layer languages for you to express your distributed processing on your data, right? So Falcon essentially alleviates you from making, you have a PickScript now, right? You want to execute it on some data, right? So it just does not end there. You want this to run periodically. You want notifications. You want some kind of monitoring on top of that, right? So Falcon just provides you all those things without actually taking you away from writing those scripts. You are responsible for writing your PickScript and HiveScript, and we just provide that script to Falcon, and Falcon just does, orchestrate these things across clusters, maybe, make sure as soon as data becomes available, it triggers your processing, right? you will have to write something else, right? A cron or something that polls and then triggers your script. So all that is alleviated, from your perspective.
Well, that's what we do today with Uzi, in a data center where you run an Uzi query.
As we explained, right, you could do that with Uzi, but with one data center. If you have the multi-cluster scenario, you basically have n number of local data centers and you have a global data center. If you want to ship all the raw data to your global data center or WAN, it's just too much data. You're just wasting your WAN, right? And it's extremely slow. So you could essentially do processing in your local data centers and ship only the aggregates, local aggregates to your global data center, and you can do global aggregation across all your local aggregates. That is very easy to express, as Srikanth was mentioning in the case study. You still write the same PIC script. It's just that you're farming the same PIC script across all the 5 different clusters. The other classic use case is hot processing, right? Nobody in the ecosystem provides hot processing for your data, right? It's still the same PIC script. If you have to do this in Uzi, you have to wire this in Uzi and put it, register these Uzi workflows across 2 different co-locations, and then manually you have to basically aggregate these results across these 2. Falcon does this automatically behind the scenes for you, right?
Question about the configuration store. It looks like you guys are saving configuration.
You have to switch for the next session, so we can't take any more questions.
Yeah, we will
Take it
this
offline.
Thanks, guys.